I'm recording a video early since I'll be out on Monday, and it turns out Monday is going to be a block day instead of a skinny day, which kind of makes things challenging. So I'm going to give you the lesson early for those of you that are on odd days. So you should be watching this in class. If you're not watching it in class, then this class, or maybe you're just trying to catch up and review the video. So the date would be November 14th. So this would be for the lesson for the November 14th and 15th. Really quickly, I will go back over this material quickly in class. We will review it, but we also have a quiz on Thursday and Friday. Don't forget about that. We're still having the quiz. This material will not be on there, though, I don't believe. Actually, I'm not 100% positive about that. There are a bunch of IXLs on this, and I think this is a really good lesson to use IXL on. You're going to just be able to do a bunch of practice problems. I've already recommended them, so you can go into IXL and see what I've recommended. And if they are too easy, then move to the next IXL. I'm going to show that at the end of the video. So first, I think I'm going to do a quick lesson just using Smart Notebook. And then I'll go into the book and I'll kind of review. I'm using the teacher's edition, so you'll have the answers and everything. And then you can do the examples on your own in the book since I'm not going to be there on Monday. Our lesson is still on parallel lines, but now we're going to add in, instead of a transversal, and I did sort of add a transversal in this picture, but that's not what the lesson is. The lesson is about being able to tell when two lines are parallel, perpendicular, or neither. And it might be from a graph, like here I've given you a graph, but more specifically, it's going to be from a set of points. So they're going to give you four, well, I don't know how many they'll give you, but as an example, they might give you four ordered pairs. They might then say, okay, are those, and it'll form two lines. They'll tell you which two lines it forms. And then they'll ask you, are these two lines perpendicular? Are they parallel? Are they neither? So the first thing we need to talk about is slope, because slope is how you determine if two lines are parallel or perpendicular or neither. So if you remember the old days back in pre-algebra, or algebra, if you didn't have pre-algebra, actually probably even before that you did slope, but there was one, oh, I'm going to have to erase a lot of stuff. You can always go back and rewind those, so I'm going to go pretty fast. So if you remember one formula for slope, when we graphed, we used this one, and we said I did that wrong. We said that it is the rise over the run. So when we graphed, we just said, okay, if I want to know the slope, I need to know how far do I go this way and then this way. And then we said, so the rise would be the height, the up and down should hopefully you remember is the rise. So that would be 3. And the run would be, and I always call it hops, 1, 2, 3, 4, 5, 6 hops. So if I put rise over run, 3 over 6. The slope is 1/2, or you could say 0.5. That's for that bottom red line. So that's one way we did slope. And then I could do it for the other lines since I already have a graph. And it's pretty easy from a graph to use rise over run. Now, when it comes to only having ordered pairs, though, and I'm still going to use the same ordered pairs, let's say we did not have a graph. And let's say we just had these two ordered pairs, and it said, let's say, a little backwards, but that's fine. So let's say they give us this. Line AB, that's a line marker, has the 2 points on it, and then I'm just going to write those points down, which is point B is -2, -3. That is probably super loud, so I'm going to turn that off. Home during this. -2, -3. And then point A would be, just real quick. and then they'd probably write like point A is that, and then point B is this. And since I'm using the lines before, oh shoot, that was point B. Forgot I wrote that. So that was actually point B, and then point A, maybe they gave you 1, 2, 3, 4, comma 0. Again, they would not have given you a line. A lot of times they're just going to give you the points on these problems. Now, if you want to graph it, you can graph it, but you won't visually be able to see that it's parallel or not, so you'll still have to go through the steps we're about to go through. So let's say they just gave you those points, and let's say they did not give you the graph. So I'm actually going to even get rid. Oh, didn't want to do that. Let's go try again. So let's say they did not give you the graph. Graph is gone. All they gave you were those 2 points. And then they wanted to know the slope of that line. So there was another formula we learned. We learned that y2 subtract y1 divided by x2 subtract x1 is the slope. So that's also a slope formula. I go through a more detailed version of this in algebra class, algebra 1A. I'm just going to tell you guys, hopefully, since you've made it this far to geometry, it's a little easier to pick up. Plus, you're going to do a bunch of practice, so that's a 1. It doesn't matter which point you label x1, y1, x2, y2. So I could call point B x2, y1. I could call point A x2. I'm sorry, never call it x2, y1. It's x2, y2. So you're basically just saying this is my first point and this is my second point. That's what the little ones and twos are. And I could flip that around. I could have made the top one my second point and the bottom one my first point. That's all these little ones and twos mean. So as long as you just make sure you keep, say it. If I'm going to subtract this, if I'm going to use the 3 first for my y values, and then the 0 second when I do this top part, so -3 subtract 0, then I better also use the top y first. So I better use this first. I'm sorry, the top x, -2, and then subtract 4. Just make sure you go in the same order. That's all that's important. I'm gonna do it in more detail, but just if you kind of are getting this, especially after you practice a bunch of IXL, that's all that matters. If you choose the top y first, then you have to choose the top x first. So now let's go backwards though, and I'll show you the real detailed way to do it. All right, so let's slide all of this stuff down a little bit. That down. There. Now we have this. Actually, you know what? I am going to slide some of it further. I'll zoom out in a second. Can sort of right in between. There we go. All right. So I'm going to go ahead and I'm going to write the x2. I am going to keep my top point as my first point. My bottom point is my second point. And I'm going to say, all right, let's do x1 here since this is my first point, and y1 here. Well, then I'm going to come down here and I'm going to say this is my second point, so it's x2, y2. Again, you're going to get in a hurry. Be careful. Make sure your first number is your x value. Make sure your second number is your y value. Make sure whatever point you're working with has the same subscript number. They should both have a 1 or they should both have a 2. You should never have a 1 and a 2 in a single point as your subscript numbers. As long as you do that last part, you should be fine. All right. Now I'm just going to plug them into the formula. Let me do now. So there's my y. A little bit so we can see the whole thing. All right, so now I just plug in the numbers. So I just say, okay, well, we'll do this in red. My y1 value is, oh, hold on a second. I'm going to really color coordinate this. Everything in different green. And what can I do for 2? Oh, I can't do that. Yeah, I can. And y2, we will make, what do we not use? Blue, green, red. I guess we can go with like dark gray. All right, now everything's color coordinated. So my y2 value, well, I just go to where I wrote y2 and I take that number. So in this case, y2 gray is 0. And then I would say subtract, and I would say, okay, I now need my y1 number. So I'm just looking at this, I'm looking at the formula right there to the left of what I'm doing. So I just wrote my y2, my y1. Well, where's y1? Oh, it's the red up there. The y1 is in red. So that is -3. Be careful. You still have to write the negative sign for the number. Just because I've written 0 subtract doesn't mean I don't include the negative in front of the 3. That subtraction symbol right here is part of the formula. That doesn't mean you get rid of a negative sign that's with either one of the x or y values. Just be careful. Sometimes students forget to write the negative sign, a lot of times actually. So I'm going to do this one in red. My y1 value is -3. Now I can write that line. So my x2 value is the blue x2, so that is 4. So I'll write that in blue. Subtract. My x1 value is the green x1 up there. Again, it's a negative number, so I have got to write -2. And now I can go ahead and I can do the math. You have a calculator, so I'm just going to do the math real quick. It is 0, subtract -3 is 0 plus 3. So that gives me, so that would give me, oh, I can just do this in black now, I guess also. That gives me 3. 4 subtract -2 is 4 plus 2. So just like I got before, I get 3/6, which is the slope of 1/2. That's a pretty detailed look at doing slope. Now I'm going to go a little bit faster. Again, you're going to practice a bunch of IXL. So once you know how to do slopes, either from the graph itself or from ordered pairs, here are the here's the knowledge you need to have, I guess, to figure out whether lines are perpendicular or parallel. So if they have the same slope, so if two lines have the same slope, so if I took this other red line on top, and I'm going to do a quick version of this. Can I zoom or zoom in? So if I took this other red line, and if I said, okay, well, let me just do rise and run since I already have a graph. So if I go from this point here to this point here, I want to make sure I pick points that are going through corners. 1, 2, 3, 4, 5, 6. 1, 2, 3. So I have the same rise and the same run, 3/6. So if I have the same slope, so that's 1/2 and 1/2, then the lines are parallel. Same slope means the two lines are parallel. Now, for perpendicular, it's a little trickier. So if I want to do the blue line and one of the red lines, since both red lines have the same slope, again, I need to figure out the slope of that blue line. Oh, that's a little trickier. Boy, is it trickier. I'm going to come all the way down here and all the way up here because that's really the only two places I am absolutely positive. It sort of looks like here, maybe I'm going through the corners of squares, but maybe not. So I'm not positive. I'm going to use the two end points because I know those end points, at least they look to me like they were going right through the corners of squares. So I'm going to go ahead and say, all right, well, Now I got to do rise over run, so this is going to be a lot more counting. I'm going to count up like this since there's more room here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now I'm going to count left. 1, 2, 3, 4, 5. So my slope is rise over run. It is I actually did that incorrectly. It's actually a negative. If I'm counting left, it's a negative run. And I know that because the slope of a line, if the line is slanting up from left to right, like these two red lines, that is a positive slope. If the line is slanting down, that's a negative slope. I just kind of know that from having done it a lot. So I wasn't worried about whether or not the 5 was positive or negative. If you understand that, you really never have to worry about positive or negative. You just know a line sloping down is negative, a line sloping up left or right is positive. If you don't understand that, then you need to make sure you put the correct positive or negative signs. If you're going right, that's positive. If you're going left, it's negative. If you're going up, that's positive. So like when I counted up and I got the 14, I made it positive 14. Up is positive and going down would be negative. Again, you can rewind this and watch. So now if I would have counted right, so let's do this a different way. I'm going to use green. If I would have counted right, 1, 2, 3, 4, 5, I would have said that is positive 5. Then though I would have counted down 14 and I would have said that's negative 14. So either way, I would have gotten a negative slope. It's just in one case, the 5 is negative, in one case, the 14 is negative. So here's the final thing. So now that I know the slope, so these are the two slopes that I have. I can kind of get rid of everything. I have it's actually rise over run. So it's 14 over negative 5. And it is the slope for the red lines was 1/2, positive 1/2. In order to determine if they're perpendicular, there's two ways to do it. One, if you understand what the inverse is, if I take 1/2 and if I make it the inverse, it's negative 2 over 1. That would be a perpendicular line. Slopes that are the inverse of each other are perpendicular. So if you don't understand that, don't worry too much. I'm going to give you a shortcut. Well, 14 over negative 5 is not negative 2 over 1. So these lines are not perpendicular. It would have had to have been positive 10 over negative 5, and it's not. So they're not perpendicular lines. Here's the other way to do it. Once you have two slopes from lines, they might just even give you two slopes and lines and problems. Or maybe they give you two equations and they ask you, actually, I'll show you that in a second. Regardless, you multiply them together. You have calculators that do fractions now. If it comes up to be -1, then they are perpendicular. So if I multiply 14 times 1, I get 14. If I multiply that times that, I get -10. That is not -1, so they are not perpendicular. Again, if you multiply two slopes together, if you get -1, they are perpendicular. And I did not get -1. So they might give you a problem maybe like this with two equations of lines, y equals 7/3 x plus 2, and then y equals -6/14 x 7, or something like that. This is the slope. If you don't remember your back in the day, your equation. Oh, I can't. Yeah, that's right. So those are the two slopes. Then if y is all by itself, this is y equals mx plus b, then those are the two slopes. If you multiply them together and you get 1, then that they are perpendicular. So I'm going to do that for you. So 7/3 times -6/14. I'm not going to be able to, I'll do the math over the side. That gives me 42 on the top it gives me, oh, look at that, gives me negative 42 on the bottom. That equals -1. So those are perpendicular lines. If I multiply them together and I get -1, they're perpendicular. What else do we need to go over? So equations of lines we did. Well, we didn't do equations of lines. So y equals mx plus b is the one I was just talking about. That's called slope-intercept form. M is the slope, which is what I just showed you down here. This was the m, the number in front of the x. Keep in mind, they can change the order, so I could write something like 14 equals 3 subtract 2x. 3 is not the slope. It's the number in front of the x, including any negative sign in front of that number. So -2 would be the slope there. So don't think that it's always the first number here that's the slope. It's not the first number, it's the number in front of the x, the number being multiplied times the x. So this is called slope-intercept form. There's another one that's called point slope form. I don't really use that one personally. I just convert that into slope-intercept form. I'll show you that one when we get to the book pages, because again, I don't use it a whole lot, but they will probably have that on the district stuff. Since that's 20% of your semester grade, we have to cover it. Let's see. So we talked about finding, again, last thing is if you had a set of ordered pairs. So instead of these lines on the graph, if you have a set of ordered pairs and they want you to determine if lines are perpendicular or not, then you could graph them and then do rise over run. Otherwise, for the ordered pairs, you'd have to do that, label them x1, y1, x2, y2, and then use this formula to figure out the slope of each line. Then, if it's the same slope, they're parallel. If it's the inverse slope, meaning you multiply them together and you get -1, then they're perpendicular. So there's an example problem I'm going to show you real quick, and then we'll go to the book. It's already solved out for you. So in your book, you may want to try to do it on your own later. So they were just asking you, we already did all of this. Actually, we did that one. Here, I'm going to give you an example here. So this is what they might give you instead of a graph. So the graph would not be there. So this would not be there. It would just give, I mean, they might give you a blank graph, but they would not give you that. Oh, we forgot about neither. So if the slope is not the same, and if the slope is like, if you multiply the two slopes and they don't give you -1, then the answer would be neither. They're not parallel and they're not perpendicular. So I forgot to mention, if they're not parallel, if they're not perpendicular, they have to be neither, meaning eventually they will intersect, is what that means. Please understand that. So they just gave us this information. So they just gave us this information, no lines on a graph. You can put the lines on a graph if you want. You know that, you know that one line, AB, oh, AB is made up of this point and this point. Remember, we know how to name points. So I could say, all right, well, I'm just going to make A my first point. Let's keep this in blue. This. So I could say that's my x1, that's my y1, this is my x2, this is my y2. Now I can do that whole process I showed you before, y2 subtract y1 divided by x2 subtract x1. Make sure you put the y values on top. Every year, not only do some people get it messed up and they accidentally get the x1 and y1 wrong, like they'll put x1, y2, and then x2, y1. Can't do that. But some people will, a lot of people actually, will wind up putting the x values on top when they do the slope. Formula is this: y2 subtract y1 divided by x2, subtract x1. The ones should be together. So let's see, I'll use highlighter for that. The ones should be together and the twos should be together. Just be careful. And then the y's should be on top and the x's should be on the bottom. Careful about it. This is, I won't say it's easy, but if you practice it a lot, it's not too bad. So let's see. I'm going to leave this one for you to do. You actually already had the answer. So if you rewind, you'll see that you have the answer over there. And I blacked out the answer underneath this black part right here. The answer is under there as well. Ooh. The answer is under there as far as are they parallel, perpendicular, or neither. Yeah, I'm not going to do that. I'm going to let you do that. You got plenty of IXLs you can practice. Just understand A, B are those 2 points, and then in green, I'll do the other line. So we'll say, well, now we'll do it in red. So then we have this point, CD. Well, CD is made up of this point. So I could say I'm going to make this. So this is a second line. That's why I'm doing the X1, Y1 thing again. And again, if you rewind the video, you'll see what I'm talking about. Oops. This is X1, Y1. This is X2, Y2. Make sure they are labeled correctly. Now go ahead, solve out, do the slope. And once you do the slope, if it's the same slope, they're parallel. If you multiply the two slopes and you get -1, they're perpendicular. If neither of those happens, then the answer is neither. All right. Let's go to the book and just, I'll show you real quick what in the book pages, the different examples. I'm going to show you from the teacher's edition, so you'll actually have the answers to look at. Can you find where it is? Oh, it's actually in yeah. So that's example 1 we just did. There you have the answers again. So now example 2. Oh, I got to zoom out. Hold on a second. Book pages. Actually, let's see. There. So this is what's in your book pages. So example 2, determine line relationships when given a graph. We already did that. It's the same concept as if you only have points. Use the slope formula. Well, I can't write on the screen right now, so I'm not at school, so I can't use the whiteboard, smartboard. So you have the slope formula. You do the same thing we did as far as here. You could just do rise over run if you have a graph already. The final answer, though, is just if the slopes are the same, they're parallel. If you multiply them together and you get -1, they're perpendicular. I could tell you these two down here are going to be perpendicular because -7/3 is the inverse of 3/7. Or I'm sorry, reciprocal. I'm using the wrong word. Inverse is just flipping it upside down, I think. So when it's the negative version of that, that's reciprocal. Negative reciprocal. So we've already done that. So here are a couple you can try to do. Are they parallel? Or are they perpendicular? I'm going to give you a short, quick version of this to tell you if they are parallel or perpendicular. If you have points that line up. So for example, God, we really wish I had. So here's a shortcut version. If I have these 4 points on a graph, I better be able to count the same distance between the lines. That's what parallel means. So here, and that would be for the entire lines, like anywhere between these two lines. If I go straight up, 1, 2, 3, 4, 5, if it's a distance of 5 right here, it should be a distance of 5 everywhere. So if I go here, 1, 2, 3, 4, 5, the line should be right there at the tip of that finger. It's not. So these lines are not parallel. You don't have to do slope or anything if you have points that you can do that with. So again, same thing. If I count from here to here, 1, 2, 3, 4, 5. Well, the distance between the lines better be 5 straight down every time. 1, 2, 3, 4, 5. Those are parallel. So again, it already tells you this down here, parallel neither. You don't have to do rise over run. You don't have to do y2 subtract y1 over x2 subtract x1 if you can clearly do what I just did. The distance between the lines should be the same everywhere if they are parallel. Doesn't really work for perpendicular. There are other tricks though, I'm sure, but so let's see. Let's go ahead and we will go to the next page. Oh, let me make sure. Yeah. I think we're good. Oh, here's the I'm not going to spend a whole lot of time on this, but this is the point slope form. Right here, you see it says the point slope form. So this 5 and this 3 is an x and y value that is on the line. Any point on the line. I could have picked any point on the line anywhere and made that this number and this number. This is the slope. So if you just say y subtract and then pick a y value off of the line, actually you have to pick a specific ordered pair. I'm going to do this real quick. Here, let's go back to this one. It's the only place I can graph. I have a graph already done. I can do this. Okay, here we go. So if I wanted to put, we'll say this, we'll do the red lines, pick a red line. If I want to take this red line, let's zoom in, just the red line. And if I want to put it in slope, I'm sorry, point slope form. Slope intercept form is the y equals mx plus b. That's where we would say, okay, well, the slope we already know was 1/2. So y, oops. So this is slope intercept form. I'm going to put the red line in slope intercept form, the bottom red line. Yeah, I can do the bottom red line. Here's the y-intercept. Remember, wherever it crosses the y-axis. So that's -2. So I would say, all right, and I know the slope is 1/2 because we already did that. So 1/2 is the slope. X is just x, y is just y. And then -2 is the y-intercept. So that's how you take a line and put it in slope intercept form, a line on a graph. Now, if I wanted to put that into point slope form, so point slope form, you say y so we would say this is point slope form. We would say y subtract, and then you'd take a y value, we'll call it y1, I guess. And then we would say equals, then the slope goes here, and then we would say x subtract the x value from a point off of the line. So I can pick any point I want. So I'm going to pick this point right here. Oh, no, I'm not. I'm going to pick this point. Let's pick that one. I don't want to use the 0. I want you to see a number. There's a reason why. So we'd say 1, 2, 3, 4, 5, 6, 1. So that point that I just picked is 6, 1. 6, 1. So there's my x value, and there's my y value I'm going to use for this. What in the world? Yeah. So this is going to be my x1, the 6. This is going to be my y1, the 1. I'm just going to plug those in. So I still have y, that first y, but now I say subtract 1 because that comes from this y value down here was 1. So I just plugged it in. So again, this God, what in the world? Why is it doing that? So this is y1. I just plugged that in for y1 right here. I just replaced that with the 1. That stuff there. We already know what the slope is because we figured it out when we did either y2 subtract y1 over x2 subtract x1, or when we did rise over run. Again, the first x is just x, and then I pull 6 from right here. My x1 value is 6. So I just replace this x1 with 6. The subtraction sign is part of the formula. Remember, that's the formula. So keep the subtraction in there. Even if there's a negative, subtraction would still be. Now, here's why I wanted to try to keep all that on screen. You will see if I were to multiply out this equation, I'll wind up getting the same exact equation as right there. So you'll see they're the same. So I'm going to do that. So I would have y1, so y subtract 1 equals 1/2 times x is 1/2 x. 1/2 times -6 is subtract 3. Now, if I want to get y all by itself, I have to add 1 to both sides. Now we solve equations. So I would get y. So now I got rid of the 1s. They went away. So y is all by itself. I still have 1/2 x. -3 plus 1 is -3 plus 1 is -2. You see I have the exact same equation. So they are equivalent equations, just in different formats. So let's go back to the book. So I just showed you that page. Examples on that. Oh, by the way, a horizontal line has a slope of 0. So if you see this right here, horizontal line, line AB has a slope of 0. A vertical line CD has an undefined slope because you wind up dividing by 0 and we can't divide by 0. Just remember a horizontal line and a vertical line are perpendicular. You determine when given equation. So again, we already talked about that. If I have this particular equation, see what is the y-intercept of y subtract 5. So you'd have to convert that to point slope form. I'm sorry, to slope intercept form. So you'd have to take this. Oh, I can't write on the screen. Shoot. You would have to take y subtract 5 equals. So ignore the 7/2 in red. That's the answer. So the 7 or the y subtract 5 equals -3/4 and then times x plus 2. You'd have to do what I just did. You'd multiply it out. So say -3/4 times x plus -3/4 times 2. And then you'd have to add the 5 to both sides to get y all by itself. And then you would have a y-intercept left. Maybe I'll go with that. You probably will see that in the IXLs. Oh, so here they have, I'll show you real quick. So there's how they solved out to get the 7. I think they got the 7/2. Oh, here's some practice problems you can try. The answers, you can try to figure out what the slope is. Again, if it's like answer or problem B and D, actually E also, you have to put those in slope intercept form to find a y-intercept. The slope is already there though. So for example, in B, the slope for the top equation is just 5. That's point slope form. So 5 is the slope. Again, if you need to rewind and look at that. In y equals 5x plus 4, 5 is the slope. So all you've got to do is just know where the slope is in those equations. 5 and 5, therefore it's parallel. So if you need to rewind and look at that. What was the 7/2? C. really do a great job of showing you how to get that 7/2 part. You can see sort of where it's in there, like they don't really show you that at all. So we'll maybe go over that. Again, I think you're going to see all of this stuff in IXL. So I'm just going to keep moving forward. If you have questions, I can help you in class when we practice together in class. Use slope to graph a line. So again, hopefully you can graph a line. If not, we'll go over that in class, or you'll do it in the IXLs for sure. What was the example? Yeah, we're not going to worry about that. And a lot of stuff going on here. Write equations of parallel and perpendicular lines. We'll save that. I'm not worried about it on this video. We'll write equations of lines when I can. All right. So there are your practice problems. If you don't have the pages or something, there's all the answers and everything. You can do the pages that you have torn out. There are the answers real quick. You can see. You also are going to be practicing IXL. So there are the answers for those. Most of you just practice the IXLs, but if you want to practice the book stuff, you can see that. Are done. So quiz will be on Thursday and Friday. Certainly not putting all of this stuff on there. I might put something simple on there about whether or not two lines are parallel or perpendicular. Mainly it's going to be on writing proofs, specifically on writing proofs that are related to line segment addition or angle addition, and then substitution's a big one in those. And it will also include parallel lines and transversal stuff. So that will be on there. This stuff we did today, I don't believe I'm going to put this on there. I'm just writing proofs and then parallel lines and transversals. So practice those IXLs after you watch this video.